Welcome to the lesson on the midpoint theorem. At the end of this lesson, you will be able to state and prove the midpoint theorem. You will also be able to solve problems based on midpoint theorem. Three friends, A, B, and C, are standing on the three vertices of a triangle. Two more friends, D and E, joined them and stood on the two sides, AB and AC, such that they position themselves midway. D and E claim that the perpendicular distance between the line joining them and the line BC remains constant. That is, line DE is parallel to the line BC. Let's check if they are speaking the truth. Measure angle ADE and angle ABC. They are equal. This implies that the corresponding angles formed by the lines BC and DE with the transversal AB are equal. Thus, DE is parallel to BC. Also, D and E claim that the distance between them is half the distance between B and C. For this, let's measure the length of the line segment DE and BC. Wow! They are right. Finally, friends D and E have successfully claimed that if they stand midway between the two sides AB and AC of a triangle ABC, then DE is parallel to BC and DE is half of BC. In geometry, this result is known as the midpoint theorem. Let's prove it. The line segment joining the midpoints of the two sides of a triangle is parallel to the third side and equal to half the third side. Let ABC be the given triangle in which P and Q are midpoints of sides AB and AC respectively. We have to prove that line PQ is parallel to side BC and PQ is half of BC. Draw a line CR parallel to BA such that it meets PQ produced at R. Here, we'll prove that the quadrilateral BCRP is a parallelogram. Let's begin with the proof. By construction, we have drawn CR parallel to BA, and from the figure, AC acts as a transversal for them. This implies angle QAP is equal to angle QCR, as they form a pair of alternate interior angles. Denote this as equation 1. Also, AQ is equal to QC, since Q is the midpoint of side AC. Also, angle AQP is equal to angle CQR, since they form a pair of vertically opposite angles. Thus, two angles and the included side of triangle APQ are equal to the two angles and the included side of triangle CRQ. Thus, by the ASA congruence rule, triangle APQ is congruent to triangle CRQ. Now, since the corresponding parts of congruent triangles are equal, PQ is equal to QR, or PQ is equal to half of PR. Also, AP is equal to CR, but AP is equal to BP, since P is the midpoint of the side AB. This implies BP is equal to CR. Also by construction, BP is parallel to CR. Thus, in the quadrilateral BCRP, we have a pair of opposite sides, BP and CR, that are equal and parallel. This implies quadrilateral BCRP is a parallelogram. Now, since opposite sides of a parallelogram are parallel, BC is parallel to PR, or in other words, BC is parallel to PQ. Also, opposite sides of a parallelogram are equal. Therefore, PR is equal to BC. Therefore, half of PR is equal to half of BC, or PQ is equal to half of BC. The converse of this theorem also holds true. It says, the line drawn through the midpoint of one side of a triangle and parallel to another side bisects the third side. That is, if in a triangle ABC, P is the midpoint of AB and PQ is parallel to BC, then AQ is equal to Cbse.